important title, infinite limits. Okay, now before we really do any of our examples, I need to tell you or kind of show you what an infinite limit is. So this is just a basic definition of an infinite limit. So here we go. It's a limit in which the function increases or decreases without bound as x approaches c. A limit in which the function increases or decreases without bound, meaning it increases or decreases forever and ever as x approaches c. So you're still approaching a single x value, whatever c is, but instead of just going to a single y value, your function could be approaching positive infinity or negative infinity. So that's an infinite limit when your answer is one of the infinities. Okay, so I'm not really calling this example 1, but you might want to kind of write this down and sort of do it along with me, because the best way to understand infinite limits is just to see them. So I'm starting with this function, f of x equals 3 over x minus 2. Now, you have your graphing calculator. You can graph this if you want. I went ahead and graphed it and then just put the graph up here so we can kind of look at it together. So this is the graph of f of x. And you can notice, actually from a couple places here, we know from our function that x equals 2 is probably going to be a place of discontinuity, because that would make the bottom equal 0. And if you look at where x is 2 right here, it doesn't show it on your calculator, but you can tell there's probably a vertical asymptote right at x equals 2. Now, let's take this graph and start to think about some limits. I'm going to put them down here. There's going to be 3 of them that we look at. So if you want to write this part down right here, you can. The first limit that we're going to find is the limit as x approaches 2 only from the left of 3 over x minus 2. I want to know what I'm approaching as x approaches 2 from the left. So remember, this is where x is 2. So if I approach 2, get closer to 2, coming from the left-hand side, look at what your graph is doing. It's not really approaching a single y value, but you can see as you get closer and closer to where x is 2, your function is decreasing without bound. It's going down forever and ever. So I'm going to say that this limit as x approaches 2 from the left is negative infinity, because it's decreasing without bound as x gets closer and closer to 2. Now, if you switch the limit and come in from the right, so now it wants us to find the limit as x approaches 2 from the right of the same function, 3 over x minus 2. You're still approaching 2, just coming in from the other side. So this is where x is 2. As I get closer and closer to where x is 2, my function is increasing without bound. It's increasing forever and ever. That is when your limit is positive infinity. You don't have to put the plus sign there. You can just put infinity, and we assume it's positive. Now, let's say that they gave you the limit without the plus or minus. This is pretty important here. if you're supposed to find the limit as x approaches 2 from both sides, well, we already kind of talked about them separately, but I'm going to do it again. As I come in to where x is 2 from the left, I'm approaching negative infinity. As I'm coming in from the right, I'm approaching positive infinity. Since those two things are not the same, they don't agree with each other, we would have to say the limit overall does not exist. But you can find it from the left and right separately just by thinking of your infinite limits, negative infinity and positive. Okay, now I've got one more type of function that I just want to kind of show you first before we get to our examples. So again, if you want to just kind of copy this function down, in case later on when you're looking back at your notes, you might want to see the graph again. I'll put the graph up here. But the function that I graphed was -1 over x minus 1 squared. That's the graph right here for that function. So I'm going to do kind of like those 3 limits again, but the value that I'm approaching this time is the value that would make that bottom equal 0, 1. If you try to find the limit as x approaches 1 from the left, what would we be approaching as we get closer to 1 from the left? Negative infinity, because it's shooting down. Okay, now what about as you approach 1 from the right, what would your limit be? Negative infinity. So in this case, since the left-hand limit and the right-hand limit agree with each other, if you were supposed to just find the limit as x approaches 1 overall, hello, thanks, this is section 1.5 that we're doing here. If you're approaching 1 overall, since you're doing the same thing, as I come in from the left, I'm going to negative infinity. Coming in from the right, I'm going to negative infinity. In that case, we could say that the limit overall is negative infinity. It goes back to the rule that we had earlier that said the left and right hand limits have to be the same. Okay, so for the first couple examples today, we're basically going to have to graph the functions ourselves on our calculator and then decide what our limit might be, depending on which side we're coming in from. Okie doke. Any ideas about the basic idea of infinite limits? Hannah, we'll catch you up here in just a little bit. I'll get some of this printed out for you. Okay, so there's, I think, just a couple sets of directions today. So here's the first one. They say determine whether f of x approaches infinity or negative infinity. Determine whether f of x approaches infinity or negative infinity as x approaches 3 from the left and right. Okay, so actually on each example, they're only giving you what f of x is, but you need 2 answers for each problem. You need to tell what the limit is as you come in toward 3 from the left, and also what the limit is as you come in towards 3 from the right. So here's example 1. Now because we're going to have 2 answers, we need to make sure and label them. But this is our function, f of x equals the fraction 1 over x minus 3. Now before I even graph this, I'm going to just label this for a second. I need to find the limit as x approaches 3 from the left, I'm going to go ahead and just put equals after that just to make it a little bit quicker. And then also I'm going to have to find the limit as x approaches 3 from the right. You don't have to find the limit from both directions. It's only the one-sided limits. Okay? Now, when you graph these, I say this all the time, anytime you graph a rational function, you have to use parentheses. You really don't need parentheses on top, but the x minus 3 on bottom needs parentheses. We'll look and see what the graph is. You can try it on yours. Okay, so this is where x is 3. Now, the first thing I was supposed to find was the limit coming in from the left. What is the limit as x approaches 3 from the left? Negative infinity, because that's what it's going toward. And then what is the limit as x approaches 3 from the right? Positive infinity, because it's increasing without bound. Now, you don't have to do this on this problem, but if it asked for the limit as x approaches 3 overall, this would be another one where it would not exist because those two one-sided limits did not agree. So that was negative infinity and that was positive. Okay, these are pretty easy to understand once you see them. You kind of know what you're looking for. Now, I'll just try one more of these before we kind of switch over here. Example 2, f of x equals 1 divided by the quantity x minus 3 squared. You already have 1 over x minus 3 in your calculator. Now you want it to be squared, so I'm going to see if I can just go over here to the end and hit, hello, there you are. Maybe I can just hit squared. I think this should be fine. I'm still keeping everything together that's in the denominator. So we're still approaching 3, so what is my limit as I approach 3 from the left? Infinity. What about coming from the right? Infinity again. It's basically just how it's shooting up or shooting down. If it shoots up, then it's positive. If it shoots down, then it would be negative infinity. Now, this limit overall would also exist. It would also be positive infinity. So there's that from the left, and then limit as x approaches 3 from the right was another positive infinity. Okay, we're just doing a couple like that because, again, once you kind of see how it works, it's pretty much the same on each one. Any questions about infinite limits? We've got one more thing we're going to talk about today, but just kind of giving you a heads up for later on in calculus. These are infinite limits when your answer is one of the infinities. We're going to get to some limits later on where the x values are approaching infinity or positive infinity. Those are what we call limits at infinity. Okay, so a little bit different. Now, the functions that we've seen today have all had vertical asymptotes. That's kind of what makes the graph shoot up or shoot down. So we're going to talk in just a little bit more detail today about vertical asymptotes. And really, this should be kind of review from pre-calc because we did a little bit of this last year. So if f of x approaches infinity or negative infinity as x approaches c from the right or left, if f of x approaches infinity or negative infinity, as x approaches c from the right or left, then the line x equals c is a vertical asymptote. When we talked about these last year, this is not the definition that we had, because in pre-calc we didn't really understand what it meant to approach a number or to approach infinity or negative infinity. So this basically means, like on the first two examples, c was 3 on the first two, so x equals 3 was a vertical asymptote. Now, in order to find them, I know this is kind of weird with our notation up here, but to find a vertical asymptote, this is it. It says a function h of x equals f of x over g of x has a vertical asymptote at x equals c if, and then this is the part that we're going to be doing here, if f of c does not equal 0 and g of c does equal 0. A function h of x equals f of x over g of x has a vertical asymptote at x equals c if f of c does not equal 0 and g of c does not equal 0. What that means is, to find the vertical asymptote, you want the bottom to equal 0. You don't want the top to equal 0. Does anybody remember from pre-calc what you would have on your graph if the top and bottom equaled 0? Been a while. If the top and bottom are 0, it's just a hole in your graph. But for a vertical asymptote, only the bottom should be 0. So for the directions here, for the last 3 examples, you want to find vertical asymptotes, if any. Sometimes you don't have any. Find vertical asymptotes, if any, for the function. Now I am putting up there show work. Okay, so yes, you can graph this, check it on your calculator, but show me how you get your answers. I want to figure out, or see how you figured out how to find the vertical asymptotes. Okie dokie. So, example 3. Don't go to your calculator yet. We're going to do this by hand first. You can check it though. It says f of x equals 3 minus x all over x cubed minus x. Now, when I gave you that information on the last slide, I mean, it basically told us what we want to happen. We want the bottom to be 0. We don't want the top to be 0. But I'm going to go ahead and just lay out a couple steps that you can use on each one of these. And the steps I'm going to put up here might make a little bit more sense than what that definition said earlier. First thing you want to do is set the bottom equal to 0 and solve for x. Set the bottom equal to 0 and solve for x. Now there's going to be one more thing to do after that. This is just step 1. So for us, x cubed minus x equals 0. I need to get x by itself. Anybody have an idea what I could do first? Yes, pull an x out. That would leave me with x squared minus 1. So now I can break both of those apart, set them both equal to 0. I get x equals 0 over here. and then add 1, square root both sides. That gives me x equals plus or minus 1. I'm going to put that right up here to save a little bit of room. Now, once you get those x values, your second and last step is to make sure none of those values let the top equal 0. Make sure none of those values let the top equal 0. Because again, if the top and bottom is 0, it's not a vertical asymptote. It's actually just a hole in your graph. So, I mean, you can probably do this kind of just in your head. Take the first answer that you got, 0. If you put that in right here for x, 3 minus 0 is 3, so that's fine. Put in a positive 1, it's fine. Put in a negative 1, it's fine. None of those are going to let the top equal 0. So this graph would actually have 3 vertical asymptotes. And you can check that on your calculator. Okay, so a couple more of these. Example 4, f of x equals negative 4x all over x squared plus 4. Negative 4x all over x squared plus 4. So, same steps here. I'm not going to rewrite the steps, but first thing to do is set the bottom equal to 0, solve it for x. Now, I'm going to have to subtract 4 from both sides, square root both sides. This would turn into plus or minus 2i, and that is not going to be a vertical asymptote. You can't have I in a vertical asymptote. So anytime that happens, you're just not going to have any vertical asymptotes. Again, you can check that on your calculator if you'd like. Okay, well that was easy. Didn't really have too much to do there. So, last one, saving the best one for last here. Number 5, f of x equals x squared plus 3x all over x cubed minus 4x squared minus 9x plus 36. Yikes, got a lot of stuff here on the bottom. But first thing, set the bottom equal to 0 and solve for x. There are 4 terms up here. Anybody remember how we solve something like this with 4 terms? Grouping. So we're doing this a lot in pre-calc right now. Pull out an x squared, you get x minus 4 left over. Leave a little bit of space and you have another x minus 4 on the other side. So what would we have pulled out of a negative 9x plus 36 to be left with x minus 4? Negative 9. Now those 2 terms come together in their own set of parentheses, and then x minus 4, you only have to write that once. Now, this, if I set this equal to 0 and solve for x, I'm going to add 9 and then square root both sides. So that gives me back plus or minus 3. Now on the other side, I would add 4 and I get 4. Now don't forget, last step, make sure none of those let the top equal 0. If you put in a 3, 3 squared is 9, you'd be taking 9 plus 9, which is 18, so that's fine. Now what do I get if I plug in a negative 3 up there for x? 0, and you can't have that So you don't want plus or minus 3. You just want the positive 3. Now 4 would also be fine. So there's only 2 vertical asymptotes. Check it on a calculator, that's fine. But you need to show your work on those so we know how you got them. Okay, so infinite limits, vertical asymptotes. They relate to the same thing because that's what you have to have in order to have an infinite limit. Okay, the assignment is kind of all over the place, so make sure you copy this down correctly. We are on page 105, and we're going to do numbers 1 to 8, 1 to 8, 15 to 23, 25 and 27, not 25 through 27, just 25 and 27, and then 33 to 35. Oh, it might be. Yes, it is. You're right. I have it on here. I have it wrong up there. Thank you. This is C25, not 4. That would not be good. So you've got quite a bit of time left here. See how much you can get done.